Hi, let us now continue with our basic commands, data types and function in R part. We now move to the next topic, which is reading and writing the data. So let us now consider this sort of a functions like write table, which is the way of writing a table format data to the file, and read table, which is the way of reading data from the text file in R. Also, we can look this sort of a function like save and load, which gives us the means to write some R object to the specific files and also then to read the R objects from specific file. So for example, we have our dataset, the simple dataset which we made last time, which has these variables x and y, and if we call that as a data and we want to write it into the R, then we can use this sort of write table where we define the name of the file, and usually it makes a lot of sense to write the data in a text file, and then we need these sort of arguments like separator, which means that how the columns are separated, and also we need this sort of a argument like decimals, that is how decimals are marked, and then we may use this sort of a quarter false and row name false to make sure that there's no extra quarter signs or characters or the row names. And then once we have some sort of a data like this simple data text file, then we can read it in a similar way, having the same sort of arguments. And if we use this sort of a header is true, then this is used, at least should be used, in a case when we have a data set where or the data file, text file, where the first row is giving us the name of the variables. So we could start looking at these sort of questions and things by using this R. So if we go here and we have just finished when we last time finished our example 1.1, then we can go for this reading and writing data part. So we have here our data, which looks like this. It's a tuple data, by the way. Now it doesn't really matter in this point, is it in a data form or tuple form, and we can then write it this data by this sort of use this write table. There's a lot of different arguments can be given in this write table function, but for us, for example, and this is what I recommend for also in the future cases, that you obviously need this sort of a separator. That is how in a file these columns values are separated. I use here what is called as a tabular. One option is that there's just space, for example, but this tabular, when it's there, then it clearly separates the columns. Decimals is clear, and then if you want to, for example, open the text file for some other programs, it is good idea to use this sort of a quarter false, and maybe it's also many cases good idea not to bring those row names to the file, because you really don't do any of them if they are just numbers. So if we write this table, use this write table function, and if I now go for my working directory, it looks like this because I have run this code before, and there's some other stuff. Now here's this simple stuff, simple data file, which looks like now this. So if I, for example, delete it, sorry, I'm about to do something else, and delete it now, and I do it again, it has now appeared here, and it looks like this. And this is basically what you should always do. So for example, if you have your file in an Excel form, just save it as a text form with the tabular delimiter form, and then it's easy to read the file into the R2. And usually it's a good idea to have in the first row the the variable names, and then continue with that. Okay, I can now read this simple data by using this read table function, and I give it as a data again name for that data, and it looks like this. And when I use the read table function, it reads the data in a data frame form, not in a tuple form, but data frame form. And from now on, during this course, we basically just use these data frames, not the tuples, but the data frames. But you should understand that these are something that may come in a near future, so that many times data frames, instead of data frames, some people may use the data in a tuple form. Anyway, so there are other things to do also here. So if I use this sort of a command as a list, it lists all the objects that are currently in a memory of this our R session. And one way to save it is to save all these elements like here for some sort of a file. And if I use this sort of a function called save, and I put argument at a list as all that is listed here, and a file name all data R data, then then we get end result, which looks like this. And here we have this sort of a, so here we have now this sort of all our data file, which basically now could be, for example, double click like this way, and if I put here like a list, it would give us all these sort of a it would open up the new R software new R software top of the existing one, and it would then have these variables available for use from now on. I will now close this one and continue with this one. Or if you just want to use, for example, we want to save the biodiesel dataset, but in this internal R form, then we can use this sort of a function save in this way. It is usually a better idea to save the data in a text file, because this takes much more these files are much bigger than these simple text files. So I recommend that if you have only your data sets you want to for example give for somebody, then this is maybe the better way to do it. However, sometimes you may have this sort of a situation that your calculation is lasting quite long, and or the data file is so big that you want to make in a step, so that you calculate something, and maybe you need all those variables for next step calculation, and in the meantime you just want to stop doing anything, then it's of course good idea to save all the needed object in this sort of R data form. So if I list everything here, like given here, and if I use this sort of a rm, which is a remove function, and I list all the object now, there's nothing. So this is basically now the empty R. This is like a starting point. There's no object in the memory. And if I use now the load all, then suddenly there's again everything available. So this is really about the reading and writing the data in R. So during this course, every dataset which you are given you should be able to read them by using this sort of a function. Only the name of the dataset needs to be changed. Otherwise, all the datasets are in such form that they are readable by using this read table in this form. So now we can move on to the next thing, which is the pointing and selecting the elements from the data. And this is quite important stuff now, in a sense that this is where the R is very good at. To point some elements to the vector, to point some rows and columns in the data sets, and maybe changing the value in some elements of the vector, changing the values of some rows or columns of the data sets. This is where the R is very good at. And this is happening all the time when we are doing something, that we are maybe pointing or selecting some elements from the data, and the best way to do it, or the most maybe simple way to do it, is to use these sort of brackets. For example, if we have a y vector, we put then after y bracket 1, it is pointing or selecting the first element from the vector y. If we have if we put this sort of, if we have a data set named data, and we then put in a brackets c 2 and 5, point 2, then it's pointing and selecting the rows 2 and 5 and a column 2 from this data frame. And and if we have, for example, this sort of a notation, it means that only those values of y are shown which are equal to 2. And in here, the last one is that only those, note that there's something which is related to the which rows are picked up, then this is dot, and nothing means that all the columns are picked up. But this part here tells us that those in the data sets with the x variable having the value being male are selected, and this basically gives a data set which only contains the values of males. So if we look these things in R, we can a little bit put more stuff on here. So if we have our data set now, I put it data again here now, so that it's the same data as we started as a data frame form now. And if we now pick, for example, in a y vector, this is not doing with the data y. Of course, we can pick the same from the data frame, like given like here. 1 gives the same value, even though it is pointing out a different y vector. So I take that out. So if you want some more values, not just one, for example, first 4 values, you can put it here, or you want everything else but not the first 4 values, then you put it in this way. Sorry. So this is not picks up every other elements but not the first 4 one. So the minus sign is there. And and the data is the same thing. However, in the data we have we have 2 points. We need to point to the rows, and we need to point to the columns. So if I put it in this way, this gives us the in a data set which has containing the rows 2 and 5. If I'm pointing out only to the column 2, then it picks up these column 2 values. If I point to the column 1, it picks up these sort of values. And of course, if we pick up, for example, first 4 observations, it looks like this. Or if we do it like this. Or, of course, we can just use in this way, or this way. Or if I put it to -2, then it gives again a first vector. Or if we had more vectors, the columns there, it would have given every other columns then, but not the second one. So that's really useful. So this is what is the good in R is this pointing and selecting elements. That is where the R is very good. Then the next one is something that first is considered this logical operation. Is y equal to 0 or not, equal to 2? Y has this sort of a value, so it's false, 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 false. So if we have put this sort of like a value like is y equal to, with the top 2 times equal signs, to 1.199, we would get this sort of a true false vector. And if we put that in a brackets of y, it would have just pick up the first element. For example, in x, we may consider, is it the value equal to male? False, true, 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 like this way. And if we pick the, for example, data x equal to male, this is now comes to the different x, and now then it picks up the data set with the to the indicator true, true, in this position where the indicator is giving a value true. And if we put here not equal to true or opposite to true to male, then we get a female data. So if I put here and on this means that it goes other way around. This is looking at which elements are not equal to male. And if we, for example, if we have y vector, we may consider the situation where the y vector is, for example, bigger than 10. Here is a cases when we have a value true, then it is true. Then we can pick up the, for example, in a y vector only, sorry, there's a typo, only those values which are true, bigger than 2. Or if we use that in a dataset case, we may pick up those rows, for example, where we have a y value bigger than 2. Of course, in this last time, we would actually it would be much more on the safe side do it in this way. So that we pick the dataset variable in this dataset, and then based on those values we which are better than bigger than 10, we point out those, we take those rows. And the last one which was here, like given this way, this is a good to understand, especially, well, I think everything else is especially, but this part is very interesting. So we kind of look in a data X, which are the values that are belonging to this group of values. So first one, because it's a female value in a data X variable, like that, it's false, 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 and when it's male, it becomes true, true, true. However, if I put here like a male and female, like this way, then everything is true. So it's not really doing anything. And if I put before this thing this way, then it says false, 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 false. So it turns all the truths, all the values the other way around. So this is a good way of picking up based on, for example, some if we have some, let's just say X, which is defining some subpopulation based on the values, then just take those certain subpopulation into account, or take the only data sets which is related to the certain subpopulation in this way. Very flexible way. So, and if we put this in the data, like for example here, and point here, then we get nothing. However, if I now take this sign out, we take whole data. If I take here only the female, I get only female. Or if I put here again like this way. So pointing to the elements and so on, that's very important. But what is even more important, or what is not really shown here so far, but it's quite interesting and it is used later, is that, for example, if we now say that we wanna there's a situation that we wanna look the data sets which are y values. Let's just say the y values. Well, let me do the first thing. Let's just define a new variable z which is nothing but a y, so that we leave our y values untouched. But then we have the z values, and we may now consider which z values are less than 10. And it's said here that, for example, that's the true, and so on, and true. And let's just say for some reason that we think that all those values which are less than 10 should actually be equal to 10. Then we could do it this way. So that all those z values which are less than 10 are picked up, and for those we point to the value 10. And if we now look at z vector, it has changed so that all those elements which were first originally less than 10 are changed to have a value 10. And that is really nice thing about R, that we can kind of point and or select some elements in a vectors and datasets, and we can then easily change the value after we have selected or pointed them to some elements. And it gives us the possibility to kind of change the datasets or include new things to the dataset, and maybe use different functions to calculate some values for these new variables or something like that. So this is pretty much pointing and selecting the elements of the datasets, and that is something that is happening all the time with R, and that is what we now gonna use in many cases, that we just take the subsets or sub rows or sub variables by using these sort of methods given here. And there are also other functions which are quite useful for handling the datasets, and those are, for example, the subset, which is basically one way of, or quite good way of actually selecting the subset from the datasets with certain conditions. Then we have this sort of order function, for example, which returns, which is the way that we can change the order of our data values in our datasets. And one of the function which is used, for example, when we go to the statistical modeling, is this sort of a factor, which kind of encodes the vector to the factor, which is then means that values are no longer meaning maybe the numerical things, but they are just values for these sort of groups or categories. So if we look those sort of things next, before we go to this simple example, is that for example, if we just want to subset the female and only, for example, the variable y from this our dataset data, then we can use this sort of a subset. First argument is the dataset. We just put this sort of a selection that x value need to be equal to female, and we select only the y variable, and this would give us the vector of female values, like here. I personally find it many times more even easier or simpler or quicker to use this sort of a pointing methods for selecting some values. But it is this sort of a subset type of selections, they are in some sense easier for someone else to read how the part of the data is taken. So the next one is this sort of order here, which is now ordering the data in some order, giving like here. So this basically what this is doing is that it tells us that which is the, for example, the highest element in this vector. So the highest element is what? This is the highest value. You can find it on the 1, 2, 3, 4, 5, 6, 7, 8 position. That's why we have 1, 2, 3, 4, 5. Oh, sorry. Here is the highest value. Oh, let us consider it again. So, I'm always confusing. I'm confused with this thing. Let me put it again. So it kind of tells us what is the order is doing. It doesn't do what I was saying. This is trying to tell us that which element is the smallest one, which element is the second smallest, and so on. So if you looked at original data, the smallest value in this data set or this vector is this one. So the smallest value can be found in a second position. That's why this order gives our first argument as a second, since the smallest one is lying on the second position. Well, the second smallest value is here, and it's actually in a 9th position. Third smallest is here, and it's a 10th position, and so on. So the order is giving us which element is the smallest one, second smallest, and so on. And if we use the word decreasing false, true, obviously, then we get another way around. So the highest value, this is the highest value, it is lying on the 3rd position. That's why it's here now, the first one. And the second highest value, which is here, it lies on the 8th position. That's why it's here in the second one. So what we use this order is that we try to, if we put it in a data set, like named data, and put it inside the brackets of like this, then it turns the whole data in order with respect to the y vector. So the smallest sampling unit is now the sampling unit which has the smallest value of y value. It now becomes as the first row, and so on. And you can now see that the row names here have changed from the original one. So this is one way of ordering the whole data set. The second thing here is that the last function which we are interested here is the factor function. So if we, for example, consider this biodiesel data set, then time and temperature and so on, they are all these sort of numerical data. However, if we are interested, we could just turn these temperature values here as meaning some sort of a classes. And if we want to do that, then we need to use this sort of a factor function. So the factor function gives us, what it tells us that it kind of keeps the variable the same, they still has the same values, but it makes it as these sort of values as labels to the categories. So, for example, if we now we can change this biodiesel, in this biodiesel dataset, the temp variable as a factor variable by writing it like this way. And then if we now show what sort of a variable this biodiesel temp is, then it has become this sort of a factor variable. And that gives us the possibility to use it in a bit different form, that variable, when these numbers are not anymore just numbers, or they are not any numbers, they are just labels to the level of temperature. And there's useful function called expand grid, that if we have this sort of a different levels for some factor variable, and we want to find all the possible combinations, then this expand grid can be used to do that. It usually makes sense to give this sort of a function the names for these variables. For example, here we could have a temp, and levels of time could be our time, like this way. And if we now click it send, then it gives us this sort of way. So each temp value, we have also this sort of a row with the different time values. So all the combinations are now here. And then we can use these sort of data sets if we want to calculate, for example, the end result of our models. Then this sort of give this sort of a grid data to the certain prediction functions and so on, and we end up having as an end result to the result of our model results, and then see how these sort of factors are affecting to the, for example, to the average level of some modeled y variable. But that's something that we then see when we go a little bit further and we start looking at those sort of statistical modeling, and then we, for example, look, for example, Duvay-Janova models. Then in those sort of situations, these sort of expand grid and calculation of estimated expected values in the different values of our categorical explanatory variables makes a lot of sense. So before we stop this video, we could still look the example 1.2 and continue with the last video then in a later time. So here in this 1.2 study, there's a rat study, and it was investigated how much weight gains in rats occur within 85 days when they were exposed to the different amount of recombinant bovine growth hormone. And our data is given here, and we are asked to read the data into our software. That is, we need to now learn how to use the read table function, and then take the subset from this data set which only contains those observations or those rats for which this x1 variable is said to have a in a third level, and gender of the rat is the female. And then we should also reorder the whole data set by decreasing values of these sort of variables. Okay, let's do that. It doesn't really take that much time to do it, but we can read it by using this sort of a read table function. Our file is like this, and separators and decimals and headers should be noted like this. So what you should do is that this data file is now available in a Moodle site. You just take it there and save it to your working directory. So in my case, my working directory is here. Change working directory, like here in R in desktop and in R folder, and I have put the dataset file there too. You noticed previously, and once it's there, you don't have to worry about, and you have set your working directory right. You don't have to worry about these paths what is the path to find this dataset file. You just simply use this sort of a code, and so this gives us the RATS data. I named this data as RATS. Now, in case of selecting only some subset of or the rows that are related to the only subset of x values, I have used here first the names function, which gives me the values of the variables, because sometimes it's hard to remember all the names for all the column names of the datasets. So this helps for that. And if I now call this sort of a subrats, this sort of a dataset which is a subset of this original dataset, so that first of all the value of this hormone level given to the rat should be bigger than or equal to 3, and these observations are those who are actually having the situation where the hormone level is set for bigger value than this level 3, and this is giving us all those observations where the gender is on the level 2. And now we want to pick up only those observations, those rats, where the truth is happening in both of these cases. And this is accomplished by putting this sort of a sign there between. So same time this should be holding and this should be holding, and only then the observation gets the value true, and it is given here. And then if I now pick from the RATS data those rows where the true lies here, this is our subrats dataset, and that's why our dataset looks like this. So the gender is 2, and this variable is getting the values 3, 4, 5, or 6 as it could only have in this case. So the last C question is about the ordering the dataset. So once we have, we want to put in order this dataset so that the highest value comes to the first, but there should be like a first those values which are related to the this combination, so that if we now order the dataset based on this variable, it means that those, if we look to the RATS data now, if we start to ordering the data based on this variable and we put decreasing is true, it means that all the values of 6 are like the first in order in the dataset. However, there are many 6 values with the 6, and thus we may need to define which of these 6 values comes first. And we can then put it in a second order, the gender, so that the first comes to 6, and those observations which are 6 then comes to the first, those one which have a highest gender value. And from those who have like a highest value for this hormone variable, highest value for gender, for those set of variables, the first one is the one that has a highest y value. And so the order then tells us in which way the data should be, on which way the observation needs to be ordered, or where we can find this sort of a highest value with the hormone level in Z as 6 and gender being 2. And if we now use this sort of a line here, then this really is giving us the data in this sort of order, that there's a first this hormone level variable which is put in an order, then it's put in a gender order, and based on those then it's data is ordered in a, as a third option is that it is ordered in a based on weight gain values. Yes, so that was it. That was our example 1.2. Then we give a little break, and then we have still one part to do with these videos, and that's in that part we will look at the matrices in R, and we look at some apply and de-apply functions in R, and then also look some simple example too.